Hello everyone. So today we are going to do a quick recap of the chapter Physical and Chemical Changes of class 7th. As we all know, the matter is divided into three parts: solid, liquid and gases. And all these three states of matter, they undergo changes. And these changes can be classified into two categories according to your grade, and that is physical change and chemical change. The term itself tells you that physical means anything which you can see and you can feel is physical change. So physically, the physical properties are going to change in these changes, while in chemical change, the internal things are going to change. So physical change, if we talk about, physical change occurs when a substance changes but no new substance is formed. If you can see in the image, there is a glass of water, and when you freeze that glass of water, it becomes ice. So the name is different, water and ice, but both of them are same. It is the water. So the moment the ice melts, it will again turn back into water, and both of them are made up of hydrogen and oxygen. So the chemical composition remains the same. And that is why the characteristic of physical changes, they include that state of substance changes. So it can melt, it can evaporate, it can freeze, it can condense. A substance is crushed, ground or cut into smaller pieces. These changes are very easy to reverse. So the physical changes mostly are reversible. The shape and the size changes, and the physical property changes, and not the chemical constituent, that is the chemical composition. Now, to brief this into one mind map, if you can see physical change, no change in the chemical property, no new substance form, it is reversible in most of the cases, and very small amount of energy is required. So you don't have to actually apply a lot of energy to it for that change to happen. It happens on its own at its own pace, and very small amount of energy is required for it. These are few examples of physical changes that you need to keep in mind while writing the examples. The first is crushing the can. So you have a can, you crush it, the can remains the can. The aluminium will remain aluminium only. You have melting of ice cube, you have boiling water. Again, when the water boils, the state changes from liquid to gases. It changes into water vapor, but it remains water itself. Then you have mixing sand with water. So even when you mix sand with water, sand is going to remain sand. It is not going to become something else. Then if you break a glass turns into small pieces of glass, but it remains glass. It doesn't become something else. Okay. Then you dissolve sugar in water. So sugar retains its property. So it is going to taste sweet only in water as it is without water. Then when you shred paper, that is you cut paper into small pieces. Paper is paper. Chopping wood, mixing green and red marble. So they don't dissolve into each other. You can just separate them physically. So again, physical changes, in few physical changes, the separation can be done by physical methods also. Now we come to chemical changes. A chemical change or a chemical reaction occurs whenever a new substance is formed. It will lead to, so the properties over here, the only difference, the major difference between physical and chemical changes, no new substance is formed. The chemical composition remains the same, while in chemical changes, a new substance is formed. So one or two or more new substances are formed. Now, apart from the new substances, there will be few changes that you will see. The first is a change in color. Like if you see something in iron, you have window grills in iron. So that's black in color. But after some time, maybe after a few years, you will see a reddish powdery thing forming out on it. And if you touch it, it will stick to your hand. That is the rust. So rust is not iron, it's iron oxide. That means there is some chemical change that has happened in the iron. It has turned into iron oxide in the presence of water and oxygen around it. That's a chemical change. Okay, so change in color is going to be there. A gas is going to come off. So in certain reactions, so it's not like every reaction, all these changes are going to be there. In few chemical reaction, colors will change. In few chemical reaction, gases are going to come out. New solid will be formed, precipitation is going to be there. There will be a change in temperature. So suppose a chemical reaction is happening and you touch it, there will be a change in temperature. Either it will come down or it is going to go up. Then there's going to change in odor. Odor is a smell. It is also going to change in few reactions. Fizzing will be there, foaming will be there. Production of sound and light. The best example are your firecrackers. So when you burst a firecracker, there is a chemical reaction happening over there, and you will be able to hear the sound, and there will be a lot of light. But if you make a paper bomb, you fold the paper and make a bomb out of it and you took, that is a physical change because no new substance is formed. Paper remains the paper. So these are few examples of chemical changes: iron rusting, burning of wood. Once you burn, so when you chop the wood, wood remains wood. But when you burn the wood, it turns into carbon, and carbon dioxide gas is evolved. Then metabolism. Metabolism is digestion process in your body. So we have studied the food we ingest, the acids, the enzymes act on it, and the nutrients are then absorbed by our body, and waste is thrown out. Now that waste cannot be turned back into your sabji and roti. Okay, so that's like absolutely non-reversible, and there are certain chemical changes which are happening. When you cook an egg, when you bake a cake using baking soda, again the composition changes, and absolutely not reversible change. Electroplating, it is done on things which can get rusted very easily, or on jewelry electroplating is done. Then rotting banana, again there is a chemical change when something rots. If you have seen, when you cut an apple and you keep it out for some time, it is going to change color. Now that's a chemical change which has happened in apple. So that is not a physical. The cutting of apple is physical change, but the color changes on apple, that's the chemical change. When you mix vinegar and baking soda, or the fireworks, everything is going to be a chemical change. So the only thing that you have to keep in mind is whether a new substance is formed or not, whether it is reversible or irreversible. When you keep all these things in mind and you have few examples in front of you, you will be able to differentiate between physical and chemical change. So the only sure evidence of chemical reaction is the production of new material. So egg becomes omelette, the puree becomes cake, the tablet becomes this. So all these things are going to be chemical changes. Now quickly we will do the mind map. So change in chemical properties, new substances are formed, irreversible, and a lot of energy is required in chemical changes. Based on the properties of physical and chemical changes that we have seen, we can differentiate these two into three main reasons. The first is physical changes are mostly reversible while chemical are irreversible. Physical, no new substance is formed, while in chemical, one or more new substance is formed. Now, because physical, there is no new substance formed, so it retains its chemical properties. While in chemical change, because a new substance is being formed, it is going to have different property with respect to the original substance. It's not going to be the same property because the chemical composition has changed. Now some chemical reactions that you'll have to study. The first thing that you see is the copper sulfate reaction. So copper sulfate powder, when you add it into water, it becomes copper sulfate solution, which is blue in color. When you dip iron nail into it, after some time you will see a reaction in which the iron nail turns brown and the solution turns green. Now this brown deposit which is there on the iron nail is of copper, and the green color which is there in the liquid, it is the iron sulfate. Now how did it reverse? So here a displacement reaction has happened. So the iron, the copper which is there in the solution has displaced the iron from the nail. It has removed the iron from the nail and it has taken its place, that is displacement. So it's a very good example of displacement reaction and a chemical reaction. The second is for production of heat and light. So when you burn a magnesium ribbon, magnesium comes in the form of a ribbon. When you burn it, it is going to burn with a dazzling flame. So this magnesium combines with the oxygen, which is required for inflammation, or which is required to burn, turns this into magnesium oxide, and this magnesium oxide is actually a powder, a white powder. When you drop water into it, it is going to become magnesium hydroxide. Then you have production of gas. So one example of production of gas is going to be when you add vinegar to baking soda. So vinegar is solution, you add baking soda to it, which is sodium hydrogen carbonate. You don't have to remember these names. Just remember vinegar and baking soda. It gives carbon dioxide gas plus other substances. And how do you check whether it was carbon dioxide gas? That is, when this gas passes through lime water, it will turn lime water milky. The common example of chemical reaction which you see around you is rusting. So rusting is when iron develops brown coating when kept in open. This substance which is formed outside is rust, and the process is rusting. For rusting, both oxygen and moisture, that is the water content, the H2O in the atmosphere, is needed. So Fe, that is iron plus oxygen plus water, is going to form rust, which is Fe2O3. So this was a quick recap of your chapter Physical and Chemical Changes. Thank you, and please do well in your exams. Please like, subscribe, comment, whatever your doubts are, and we'll be there for you.